All right, today is topic 1.0 scientific notation. We're going to get three things out of this lesson. It's going to be how to put a number into scientific notation, how to take a number out of scientific notation, and finally, how do you enter it into your calculator. So, in chemistry, we oftentimes work with numbers that are very large and very small. And so, if you had a 12-gram sample of carbon, so it could be like charcoal or it could even be diamond. So, if you have 12 grams of it, if you had wanted to count the number of atoms, this is how many atoms would be in that number of grams of carbon. So a very, very large number. And so lastly, if we want to know the mass of just one of those atoms of carbon within that 12-gram sample, so just a single atom, this is the mass of one of those. So a very, very large number, very, very small number. So what can help shorten that up is by utilizing scientific notation. So I don't expect for many of you this to be a new concept, but the main thing is I want to make sure that you can correctly enter it into your calculator because we utilize this throughout the entire year and we want to make sure that we start out on the right foot. And so to start out, we can kind of set up a number in scientific notation using this format. Capital N times 10 to the nth power with a lowercase n. So what that means is that first number with the uppercase n, this should be a value between 1 and basically 9.9. Repeat it, okay? The little n is where you put an exponent, and your exponent has two options in scientific notation. You can have one that's positive or negative, okay? And that tells you a couple of different pieces of information as well in terms of if it's positive or negative. So I have two examples to start with to put a number into scientific notation. So we have 568.762, and so the first thing is we need to move to the decimal. And so we're going to move the decimal to the left in this example. And the reason why is that our value here is greater than 0. So the decimal is already put into the number for us. And so you always move it so it's resting behind the very first number. So when it's greater than 1, you want to rest it right behind that first number. So what I do is I draw these little waves. So that's 1, 2, and that's essentially showing what direction and how many times the decimal is moving. So when I rewrite this, this becomes 5.68762. So I end up with a number that's somewhere between 1 and 9.99. So again, you rest it behind this very first number. Then we have our times 10. And the next thing we need to describe is how many times we moved the decimal. So we moved it to the left twice. So this is going to be to the second power. Lastly, you have to decide if you want a positive or negative exponent. We're going to have an exponent that's positive because we moved the decimal to the left. Now, if we take a look in the example on the right-hand side, we're going to move the decimal to the right because we are working with a number less than 1. So then we have n is less than 0. So we're going to go ahead and figure out how many times to move the decimal place and where to rest it. So when a number greater than, you move it to the left and rest it behind your first value. In this example, you're going to move it to the right, and you want to move it to the point that it's behind your very first non-zero digit. So I'm going to draw my little waves in. I have 1, 2, 3, 4, 5, 6. Again, decimal rests behind the first non-zero. So what this does is it helps us eliminate these extra zeros and essentially kind of simplify the number. So it represents the same value, it just makes it a little bit easier to interpret. So what this becomes is 7.72 times 10. And again, we moved it, so if you count your number of times that it was moved 6 times. So our exponent is to the 6th. Now this is going to be slightly different in this example compared to here because this value was less than, so it's going to have a negative exponent. So when they're greater than 0, we're going to have a exponent that's positive. When it's less than, it's going to be negative. So I have 4 example problems here to practice through, making sure that you're comfortable putting a number into scientific notation. When you take a look at these, this first one, there is no decimal in the value compared to what I was given, that I gave you as examples at the beginning. So we can assume that the decimal is always resting there at the end. So the next thing you ask yourself is, what direction is it going to move? It's going to move to the left. And it's going to move to the left 2 times. So this becomes 7 times 10 to the second power. Again, it's going to be a positive because it's greater than 0. Example B is very similar. We can safely assume that this is where the decimal is at the end, even though it's not directly wrote in. Again, I would recommend that you draw your little waves to count the number of times that you're moving it. Again, where do you want your decimal to end? It's going to end and rest behind that first number. So it becomes 6.58. Our goal in scientific notation is to not write all of those zeros out, so we can eliminate those. I'm just writing in my non-zero digits, so the 6, 5, and 8. And this is going to be times 10. And again, how many times did you move it? It should be 11 times. So it's a positive because it's greater than. So in example C, we are working with a number less than, so the decimal is going to be moving to the right in these examples. So in these first 2, we again rest it behind the very first number. When you move the decimal to the right, you rest it behind your first non-zero. So that's the 5. So this becomes 5.4 times 10. The number of times that you move your decimal place is 3. And then we're going to have a negative there to indicate that this was a number less than 0, and we had to move it to the right. So you're going to do the same thing in example D. When you rewrite this, again, we can eliminate these zeros, so it becomes 7.6 times 10. We moved it 9 times to the right, so it's 7.6 times 10 to the negative 9th. So again, this is how you put numbers into scientific notation. So moving on to our next concept is, how do you take it out of scientific notation? So the couple of things you have to look for is, what's your power, and is it positive or negative? So with this first one, what I would recommend that you do is write your base number, your 3.60, and it's to the power of a positive 5. So that means it was a number greater than 0. So when you put it into standard notation, that means that we're going to be moving the decimal place to the right, and you're going to move it the number of times your exponent is there. So this is 1, 2, 3, 4, 5. This is where my decimal ends. Now, these gaps is where you fill in zeros. Again, the goal of scientific notation is to eliminate those zeros. When you go to rewrite your final answer, then we can rewrite this as 360,000. So these two numbers are the exact same. Again, it's just a matter of how to represent it, how to work with those values. So in example B, we have 5.4 times 10 to the negative 5th. We have our decimal ready to go. It's to the negative, so when you have a negative exponent, putting it into standard notation, we are going to move it to the left. So this is 1, 2, 3, 4, 5. This is where the decimal is going to rest. In those gaps is where we can fill in zeros, and I'm going to go ahead and rewrite my final answer. When I go to rewrite this, 2, 3, 4, 5, 4. So that's what my final answer should look like for this particular example. Now, if you didn't put a 0 in front of this decimal, that's fine. I like to always have a 0 to the left of my decimal. Okay. So the main thing I wanted to get at is how to put this into your calculator. So anytime that we work with scientific notation, students oftentimes think they have a way of putting scientific notation in, but oftentimes there's an easier way to do it than what you're currently using. and depending on your model of calculator, it might be different. So you might have to pause and kind of fast forward depending on what calculator model that you have. So I'm going to start with a graphing calculator. If you have a graphing calculator, how you type in scientific notation. I have a much easier way for you to do this. Let me turn on the light to this. There we go. We can see the screen a little bit better. So how do I type this into my calculator? So what I do is I type 2.76. Now, how do you do times 10 to the second? This is where you need to listen and do this step because I have a much easier way than probably how you're doing it currently. You're going to hit second, and then this button right above 7 is a comma. If you notice, and it's kind of fuzzy, there's a light blue EE. It does not matter what type of graphing calculator you have, that function is the same on all. So all I did was type second, comma, and that E showed up on my screen to the second. This and this is the exact same thing. Times 10 is represented here by this uppercase E. So what this helps you do is it eliminates the need for parentheses and issues with order of operations. What you would then do is type times 1.09 to get that times 10. I'm going to do second EE. There's an E that shows up on my screen. 1. And again, that E function was with the comma. So I'm pressing second, comma. And you get an answer of 3008.4. Another style that's very similar with the TI brand is this TI-30X. There's different variations of this, but for the most part, they're all the same. You might just have one that's a different color. It's a pretty similar setup. So you're going to go ahead and type 2.76. Instead of this being a comma, it's x to the negative 1, but you still need to press that second. So second EE, again, in this particular style, everything above the function is in yellow. So in order to use those, you use the second button. I get my uppercase E on the screen to the second times 1.09, second x to the negative 1 to get that E to the first. And again, I get 3008.4. Another style of calculator that's a little bit different is this TI, but it's this multi-view. This one is a little bit of a different setup altogether. If you have this style calculator, you're going to use parentheses, and then you're going to type in your 2.76, and then about smack dab in the middle of your calculator, you should see a times 10 to the nth. Hit that and type in your exponent 2. This part is important. Close the parenthesis. You're going to hit times parenthesis 1.09. Now again, go back to that times 10, and then you're going to type into the first power, and we get that 3008.4. Here's one with Casio. If you turn that particular calculator on and you type it in, we're going to use 2.76. This particular calculator doesn't have an EE button, but what it has is an exponent button, which is the exact same thing. So you can see this 2.76 E, and I got that by just hitting the EXP button. And to the second, I'm going to go ahead and do times 1.09 exponent to the first. Hit equal, you get 3008.4. So that's 4 calculators that I have floating around that either I own or somebody has left behind over the years. That doesn't mean these are the only calculators out there. And so if you have a different style calculator and I didn't cover that for you, please feel free to send me a picture and email it to me, and I will gladly tell you what you need to type into your calculator to make it work. So again, I was only able to show in terms of calculators that I have. So buzzing through the rest of these, we have 3.26 times 10 to the first. So get your function to the first power plus 1.77 to the negative first. You get 32.777. We'll talk about rounding later on when we get to significant figures later on this week. These particular 2 answers, I'm not going to worry about scientific notation because they're not very large and they're not very small. So scientific notation would probably not be the best means of recording an answer. Okay, so I have number 3 typed in, Notice that they're negative exponents. I get an answer of negative 0.5465. And lastly, 2.33 to the second power divided by 5.9 to the second power. We get 0.39. And I'm just going to leave it at 0.3949. Like I said, we'll talk about where to cut numbers off later on. So the main goal of what I need you to get out of this lesson is how to put these into your calculator. Again, if you're unsure or it's not coming out correct with the 4 styles that I showed you, please send me a picture. If you could show me how you're typing it in, that helps me save fewer emails in between so I can have a way to help you. Again, if you have a particular calculator that I did not show, doesn't mean it doesn't work. I just don't have one to show you. So send me a picture of what you have, and I can tell you how to type it in with your particular calculator style. Again, please reach out to me if you have any questions or concerns.